What do you see about this? Is it 0 or non-zero? Non-zero. We're going to call this the first pivot. And then I'm going to ask you this question. Do you think that you could use linear combinations, or excuse me, do you think you could use matrix multiplication to multiply a scalar times this matrix, this row, add it to this row, and get a 0 out? Yeah, so let's 0 out this entry. Why would we want to 0 out this entry? Because if we had this thing in an upper triangular form, what would you all do? That's it. I can do that in my sleep, sucker. Right? I mean, maybe you couldn't do this in your sleep yet, but in a few weeks, right? Okay, so the whole idea is, let's use linear combinations of the rows to get a 0 right there. Let's do that via matrix multiplication. If I'm going to multiply this modeling matrix, and I want to take linear combination of the rows to cancel that thing out, which side am I going to multiply on? It's almost like we spent the last few weeks of our life thinking about that just so we could do this problem, right? So we're going to multiply this on the left. What are we going to multiply by? Which row do we want to change? First row. Is it the first row? We want to use the first row. We want to use this to cancel out that one, right? So we're going to cancel the third row. If we're only going to cancel the third row, what do you say about the first two? Don't touch them. So what's the first, if we think about this whole structure, what's the first row of the thing I'm going to multiply by? 1, 0, 0. Because what does that thing do? It does nothing to the first row. What's the second row? 0, 1, 0. So now I'm going to have 1, 3, 9, 1, 3.3, 10.89, 1, 3.6, 12.96. And then I'm not sure what these entries are supposed to be. I'm still shopping for these, so to speak, right? Oh, sugar. And then I'm going to write this thing a little bit further out. Why would I give myself that extra space? Anything I do to the left-hand side of an equation, what do you claim? Got to do it to the right because it's equal, right? I can't just change one side and not change the other. If I did that, I would be called Wells Fargo, right? OK. So now the question is, well, I want to take a linear combination of rows 3 and of 1 and 3, and when I take this sum, I want it to be 0, right? So I'm not going to use any of row 2. Do you have a matrix that we've talked about taking a scalar multiple times one vector, adding it to a straight copy of the other vector, and then seeing what the output is? Yeah, let's go ahead and call this thing C, and we'll call that 1. In which case, this matrix right there, what's that called? Yeah, which shear matrix is it? S31 of some unknown C times the matrix A, right? And what's the thing that we want out? Well, do we really care? I guess I got to be a little bit non-cavalier. Let me go run and get that eraser. What's the only thing we care in terms of the sparsity structure? Yeah, we don't really care what any of these are, but we for sure want a 0 right there, right? OK, so let's go ahead and target this. This is where algebra comes in. So what entry is that? Entry 3(1) of the product S31 of C times A. We for sure know that we want that entry to be equal to 0. Well, what is entry 3(1) of this product? Well, it's going to be, based on our entry by entry definition, it's going to be row it's going to be row 3 of the left-hand matrix times column 1. So this is going to be row 3 of S31 of C, whatever that is, times column 1 of A. And we know that for sure we want that to be 0. Who told us we want that to be 0? Our friend Drake, right? Because we want to start from the bottom and we want to go here. That's what that song's about, right? Backward substitution, no? All right, what is S31 of, what is row 3 of S31 of C? C0, 1. You're a little bit ahead of me, Joe. What's column 1 of A? 1, 1, 1. Okay, so now what do we have? C times 1 plus 0 plus 1 times 1 equals 0. So what does that immediately mean about C? Negative 1 divided by 1. Because you got to be a little careful. If this was A11, A21, A31, you'd have a different calculation now, right? So I just want to track that this is actually coming from a multiplication of the fact that this is, yeah, so really, you know what we should do, right? You know what I'm about to do, right? Because I want you to see the pattern. What's the pattern there? Let's go ahead and check. So this is going to be C times A11 plus A31 is equal to 0. And what's the claim about C then? Negative A31 divided by A11. This is, of course, under the assumption that this thing right there has to be non-zero, right? Has to be non-zero, which means that the pivot that we choose, that's the thing that we're pivoting around in the sense that we're using that pivot as a way to eliminate the associated location, right? So in this case, what was A31? Well, it's the least interesting A31 and A11 combination. What is it? Negative 1 divided by 1. And then it's Monday, so negative 1 divided by 1 is, of course, negative 1. God bless, right? Tuesdays are real dirty, right?